Hey guys, I want to make a quick video about buoyancy and Archimedes' principle. The principle states that when you put something into a fluid, if that thing pushes aside an amount of fluid equal to the weight of the thing, so if the weight of the fluid moved aside is equal to the weight of the actual thing, then it will float. Okay? And here's some math for you. I'm going to go through that here in a minute. Okay, so this is the thing. So, fluids exert buoyant forces. There's a buoyant force going on here. Usually when I'm doing this, I have something like this. So this is kind of a neat little thing. I can get this thing to move up and down in the water just by sliding the density slider back and forth. So I have a block and it is floating. If it's floating, what do we know? Right? Balanced forces. Okay, so what are the forces acting on this block? How many forces? What are they? Yeah, so the forces, I'm going to show the free body. There they are. We have two forces. Buoyant force and the weight of the block. Okay? This is a field force, this weight force, because it's not actually touching the center of the earth. In fact, technically it's not really touching earth. I mean, it's touching water. This buoyant force here is a contact force. So there you go. Okay, now we're going to take this and create an equation, right? Since these forces are balanced, we can say that the buoyant force upwards is equal to the weight going down. FB I call buoyant force, mg, right? So I have my buoyant force going up. This is the water line. There's my block. FB is up, mg is down. Here's my equation, right? Net force would be 0. I could actually make this say equal to 0. Done. Okay. Now, I'm going to fiddle with this. Density is mass divided by volume, right? And so what I'm going to do is I'm going to solve for mass. I'm going to say, what is mass? Well, mass is therefore equal to density times volume. That thing go away. Mass is equal to dV, dvol. So what I'm going to do is I'm going to take this dV, I'm going to stick it in right here where there's a mass, where there's an m. Plop. Put that in there. Get in there. And there we go. I get this equation. FB is equal to dVg. Density times volume times gravity. Okay. I go back to here. There we go. Buoyant force is equal to dVg. This is rho, actually. It isn't d. So your buoyant force is equal to the weight down, which is equal to rho Vg. This is the density of the fluid. This is the volume of fluid displaced. And let's think about this. The volume of the fluid displaced is equal to what? So if I go back here, right? Let's say that we put this thing and we have it submerged fully. Say it's fully submerged. Is it floating? Yes. Are the forces balanced? Yes. What is the volume of fluid displaced? It's equal to the volume of the thing. Okay. Now if it's floating like this, then you have a little bit above, a little bit below, and so it is a little tricky. The problem will probably have to tell you what volume is displaced, or you might be solving for that. I don't know. Okay. But buoyancy is simply, can you draw a free body? Can you manipulate equations? This is the equation, rho Vg. Okay? This is what our picture usually looks like. It can get more complicated because what if the block is, trying to carry something? What if we have a certain load? What if this is a barge or a tug or a boat and we want to have it move something, right? Well, then you're going to have more forces. And that gets a little trickier, so you have to be able to draw good pictures. Okay? But this is the thing. So to recap, an object floats when its weight is equal to the weight of the fluid it displaces. Full stop.